So what if I told you that everything you see, the stars, the planets, the very laws of physics, all of it sprang from a single fundamental particle? Today, we're diving into a really radical theory called the TKU model. And yeah, it proposes exactly that, challenging, well, pretty much everything we think we know about the cosmos. Just let that sink in for a second. We're not just talking about where stuff came from. This idea suggests that every single law of nature, every force we see out there, is just a giant echo of something happening deep inside one tiny particle. It's a massive, mind-bending claim, and we're going to unpack exactly how it could possibly work. Okay, so you might be wondering, why do we even need a theory this out there? Well, it's because for about 100 years now, physics has been dealing with a major problem. Our understanding of the universe has, for lack of a better term, a split personality. See, on one hand, you have general relativity. That's Einstein's masterpiece, right? It describes the big stuff, planets, stars, galaxies, with incredible elegance. But then, on the other hand, you've got quantum mechanics, the bizarre, totally weird set of rules for the tiny world of atoms and particles. And here's the kicker. They just don't get along. They give you completely different answers to the same questions. For a century, the greatest minds on the planet have been trying to connect these two worlds, and they just haven't been able to do it. But what if we've been looking at the problem all wrong? The author of the TKU model, Luis Fernando Conejo Chavez, basically argues that this whole separation of big and small, that was the original mistake. The theory's starting point is that there is no separation at all.
So if the big and the small are really one and the same, how on earth do you see the connection? Well, the TKU model gives us a new way to look at reality, a concept it calls the cosmic microscope. And we're not talking about zooming in on smaller things. We're talking about focusing on different scales of reality itself.
Now, this is absolutely crucial. These scales aren't physical layers, like an onion you can peel back. Nope. They're different levels of energy density, all coexisting inside that one particle. So it's less like peeling and more like turning the focus knob on a microscope. As you turn it, you're not seeing a smaller object. You're seeing a more intense, more energetic layer of the same object.
So what this means is that as we zoom in, we're moving from our world, the macro scale, through these deeper and deeper scales where the energy density just keeps going up. And the theory says that the unified blueprint, the ultimate truth of how everything works, is hiding at the deepest, most energetic level, the particle scale. So what happens when energy moves between these scales? The model calls it a density jump, like a sudden waterfall of energy cascading from a high level to a lower one. And get this isn't just some neat little thing happening inside the particle. This internal jump creates a real physical tension in the actual fabric of spacetime all around it. Okay, this internal energy dance is cool and all, but it brings up the biggest question, right? If it all starts as pure energy, how do we get, well, stuff? You know, the solid ground, the chair you're sitting on, all of it. The answer, according to the model, is something called the ECES process. You can think of this as the universe's creation engine. It's the actual mechanism that takes pure, formless energy and turns it into the tangible matter of our world. Here's how it works. Deep inside the particle, this pure energy, called symmetry energy, starts clumping together. As it gets more and more dense, it holds this perfectly stable symmetrical pattern until it hits a tipping point and bam, it condenses. And that little moment of condensation, that is what we experience as physical mass. Okay, so we have mass. That's a huge step. But how does this tiny little process create the giant forces that run the show? How does it explain gravity? Or that mysterious stuff we call dark matter, the invisible glue holding galaxies together? This is where the model just flips the script on gravity. It says gravity is not a pulling force. Not at all. Remember that density jump? Imagine it creates a huge dip in a rubber sheet. That's what the jump does to space-time. It curves it. So planets and stars aren't being pulled anywhere. They're just rolling downhill along this curve that the energy density creates. And what about dark matter? The mystery that outweighs everything we can see 5 to 1. Well, the TKU model's solution is kind of beautiful in how simple it is. It's not some weird, exotic new particle. It's the exact same stuff as you and me, just condensed on a deeper, more energetic scale. From where we stand, it's invisible because it doesn't give off light, but its mass is still there, acting as the hidden gravitational scaffolding that keeps our galaxies from flying apart. So we've got an explanation for matter, gravity, and even dark matter. But what about the biggest observation in all of modern cosmology?
The fact that the entire universe is expanding, and that expansion is speeding up. What's driving that? Well, the model suggests that when energy condenses to form matter, there's some leftover energy. You can think of it like cosmic scraps. And this energy, which it calls K-essence, is the total opposite of matter. Matter is clumpy, heavy energy that creates gravity. K-essence is dynamic, pushing energy that actively shoves space apart. So K-essence is literally the engine of the universe. It's the leftover energy from creating matter. And its whole job is to flow between these scales, constantly stretching the fabric of space and flooring the accelerator on cosmic expansion. And this is where the theory goes from being a cool idea to something you can actually test. It doesn't just say the universe expands. No, it calculates the exact value for the cosmic expansion parameter, a number astronomers are desperately trying to measure right now. And the theory predicts that value is precisely -1.03. Now, that number is everything. Our current best models of the universe predict that value should be exactly -1. That tiny difference, that extra 0.03, is the smoking gun. The TKU model says that's not a mistake, it's the mathematical fingerprint of K-essence, proving that the energy pushing our universe apart is alive and dynamic. So let's just step back. If this model is right, if matter, gravity, dark matter, and even the expansion of space all come from the inner workings of one particle, what does that say about the reality we experience? This brings us to the theory's most profound and, frankly, startling conclusion. The model basically says that everything we see, all the stars, the galaxies, space, time itself, it's not the fundamental reality. It's just a shadow, a projection of the unified, real processes happening on a much deeper scale inside that particle. And this isn't just poetry. The whole theory is built on a single master equation called the unified Lagrangian. Think of it like the mathematical source code for reality itself. It's the proof that shows the micro and the macro are two sides of the same coin, that a tiny little flutter of energy inside the particle instantly echoes across the entire cosmos. And that brings us to this one mind-bending phrase that just perfectly captures this whole worldview. Reality as we know it is a macro mirage. So the TKU model leaves us with this huge, lingering question. If our vast, complex universe, everything we have ever known or will ever see, is just an echo, just a large-scale reflection of an unseen world inside a single particle, then what even is reality?